Now, we've talked about normal distribution before. We've talked about a normal curve before. Now we're going to spend a little more time getting to know it better. The first few slides I'm going to put up here, you don't necessarily need to input into your notes, but just look at the screen so you've got an idea what we're talking about. If you decide later on that you want to go back and put those into your notes, there of course will be a video that you can go and screenshot from there. Okay. So first things first. All right. If you should remember these. Okay, this was what our normal curve looked like. It was uniform. The mean, median, mode was all lined up. A left skewed meant the median and mode were to the right of the mean. Okay, the curve was actually pushed to the right. That's a left skewed or negatively skewed curve. And then the opposite over here. We're going to spend our time focusing on this, but I wanted you to see all those just to refresh your memory about those types of curves.
Which one are we focusing on?
The middle one. In fact, this curve you have also seen, okay? With the percentages broken out, 1 standard deviation away is 68% of the data, 2 standard deviations away was 95% of the data, and 3 standard deviations away from the mean was 99.7% of the data. We're going to actually look a little more closely at how that is broken down because we're going to investigate those areas a little bit. And this is something we need to focus on, okay? On page 305 in your book, is the normal curve broken down a lot more precisely than what we've seen before? Inside here, in between the 2 standard deviations where we've known it as 68% of the data, it's actually 68.26% of the data, 34.13% and 34.13%. And then we can add on to that all these different amounts. And one of the things that we're going to be doing in 6.1 is trying to find the area under a normal curve. The area under the normal curve right now is 100% or 1. Okay? And we're going to be able to find the area under the normal curve for different standard deviations. Okay? One of the main things we need to understand is that the z-score or the z-value, we've talked about that before, and the standard deviations away from the mean are the same thing. So we're going to talk a lot about the z-value or the z-score in chapter 6.
Oh man.
And the z-score or the z-value represents the number of standard deviations away from the mean. So these numbers down here, while they represent how many standard deviations they are away from the mean, it also represents a z-value or a z-score. Okay? So those things can be the same, can be interchanged. Number of standard deviations away from the mean and the z-value or z-score. So next. Okay, so this on 305, okay, it's basically going to tell you all the different things that have to be done. There are 3 ways of looking at area under the standard normal curve. And that's what we're going to be spending 6.1 on, finding the area under the curve. So the key thing is, and this is true about your table E, and I'm going to show you how to use table E in a minute, but the table E measures the area to the left of any given z-score. So for example, on these 2 pictures, if I were to look up this z-value, table E will tell me this area over here, all the area to the left of that z. If the z-value is negative, it would still tell me the area to the left of that negative z-value. Okay? So when you use that table, the numbers represent the area to the left of that particular z-score. I'll show you how to use the table here in a minute. Okay? That's the first thing that's going to happen in this section. Okay? The second thing that's going to happen is sometimes it's going to ask you for the area to the right of the z-score, and you do something a little different there. Okay? So in these 2 examples, it's asking, it would be looking up, it would be asking for the area to the right. And I'll show you examples when that changes. Okay? And what you would do here is since the table tells you the values to the left, we would actually go 1 minus this value. because it's going to subtract off this area. 1 minus this value. Since the value in the table tells us all of this, 1 minus that value, this area, will give me what's left over. Okay, and then the other situation that we have is when we're looking in between two z values. So this one is sort of like less than the z value. This one's greater than the z value. We have an interval in between the z values, and then you're going to find those two and just subtract them. Okay? And so whether it's a positive and a negative z value, or two positive z values, or two negative z values, you're going to subtract the left z value from the right z value, because essentially what you're doing is taking this portion out. All right, that's where they overlap. It'll make more sense when we look at some examples. Okay. Again, this is on page 305 in your book if you want to grab it that way. So let's look at an example. Here's the kind of problem that you're going to have. Okay, it's going to say find the area to the left of where z equals 1.99, meaning the z value is 1.99, or almost 2 standard deviations away from the mean, above the mean. And for this situation, all we're going to do is use the table to find the value. Okay? And now you don't necessarily have to draw the curve, but some of the problems will ask you to draw the curve. So just to be clear, what we're talking about is we're looking for the shaded area here. Okay? This is 1.99, again it'd be 1, then 2. And so what we're looking for, the area to the left of 1.99. And the table E, gives us the area to the left of the value always. So in this case, all we have to do is look up 1.99 in table E and take that value, and that will tell us the area under the curve that's shaded in. Okay? So here's how you read the table. Here's how you read the table. So look at table E. The side column is going to be the everything to the 10th place. So the 1, 9 of the 10th place. So, and it's always going to go like that. So the first, you're going to split between the 10th and the 100th. In other words, right here is where the table splits, and that will always split like that. So the first 2 digits, or 1 digit past the decimal, will be to the side, and then you will go across the top for the 0.09. All right? Because when I add those two together, I get 1.99. And here's what the table looks like. So I put a picture here so you can kind of see it. I know it's super small and it's hard to see, especially because it doesn't fit on the screen. Nope. Let's see. Okay, so notice here, on the left is 1.9, on the right 0.09, and notice across the top it starts at the thousandths place, right? And so this 0.976, that's the area under the curve, which means, here's what it really means, 97.67% of the area is left of 1.99. Okay, so let me show you that. There it is. Okay, and another thing that means, just so we're clear, so 97.67% of the area under the normal curve is less than that z value of 1.99. And you just pull that off the table.
Looks about right now.
Okay? Right, most of the area is covered. I mean, it's almost 100%. We've got this little part over here that's not shaded in. Okay? Now, another way that this type of problem is going to be presented to you is like this. Okay? It'll ask for the probability of z less than 1.99. Okay?
Then you have 0.01.
And then, no, so then it would still be so this probability, this is how this all ties together. This could also be used to find the probability. The probability is 0.9767 or 97.67%. So we can apply the normal distribution to probability experiments if it's a normal situation, which we will talk about later on in this chapter.
Wait, where'd
Okay?
you?
So then, like I said, the probability would have been 97.67%. Okay? Look at another example. Okay, now this is the area to the right.
Ooh, use the other chart.
Okay, we are gonna get to use the first page now. The area to the right of z equals negative 1.16. And again, sometimes they're gonna ask you to draw it, sometimes they're not. This is what we're talking about. We're trying to find the area to the right of negative 1.16. Remember, table E only gives us the values to the left. So if I looked up table E, if I use table E and I look up this value, it's going to tell me the white area. That's what the table E value will say, because that's the left of this. Which obviously this is not the area I want. I want this area over here. So when it's to the right, you take the value that it gives us and we subtract it from 1, and that'll give us the rest of it. You have the answer?
0.877.
Okay. You say 0.877? Well, let's see. Okay. So first of all, here's what it looks like. We're going to go 1 minus the table E value.
What do you mean?
So find the table E value of negative 1.16. And then you're going to plug it in right for that, where it says table E value. Because again, the table E only tells us the area to the left. And we don't want the area to the left, we want the area to the right. So what is the table E value?
0.1230.
Okay, let's start there. That's 0.1230 is the table E value. Which essentially what it's telling us, that is this area in white, which is not the area I want. I want the rest of it.
Correct.
So that's why I subtract it from 1.
And you get 0.87.
You go 0.8770, put the 0 on there. Okay? So 87.70% of the area is to the right, or greater than, if we get to probability. Okay?
Are we gonna have to memorize table E?
Next. Okay, so when we find in between, okay, when we find in between, we take the table E value for the bigger number and subtract the table E number for the smaller number. Okay?
Don't pop.
Again, here's what it looks like, right? Because what we're doing essentially, if I just took this table E value, this would give me all of this to the left, including this white area. So what I'm essentially doing is I'm going to take all of it to the left and subtract off this area, and that's how I end up with this. So the table E value here minus the table E value here, that will give me the area in between. Go ahead and give that a shot.
Yeah.
Table E value for the right minus the table E value for the left. And what I mean is the right Z value and the left Z value.
So what you get?
Well, here's what I got so far.
6.
Did you get that for your work?
Oh, yeah.
Yeah.
And should have got 0.8682 or 86.82%. How many had that?
Don't you have to take it away from 1?
Nope.
Fool would not get that.
Okay. So when it's an interval like that, again, you take the higher Z value, table E value, subtract the table E value for the lower Z value. So many values in one sentence. Okay, one other thing we have to do in this section. Sometimes they will give us the area and you have to find the Z value. So basically do it all backwards. And so what you're going to end up having to do is find the area or the decimal in the table and line it up to the Z value. And sometimes you're going to have to subtract from 1 because it's to the area to the right and that kind of thing. But anyway, here's the equal I want to look at. Okay, so for example,
5.05.
okay, so since this is area to the left of Z, the table E value will just be there. Okay, and so the Z value that corresponds to this is my answer.
Oh, I got it. It's 1.65. Wow.
Is she right?
She is right. She is right.
She is right. So in the table, you just find that 0.9505, and then so that corresponds to that value. Now, let's say, for example, let's say they gave us the area to the right. Okay? What you would have to do is subtract that from 1, because that's the value that will appear in the table.
What, so subtract, what's the number they give you?
So if they would have shaded this in, and it was, well, obviously it would be 0.0495, right? So if this area was shaded, it would say 0.0495. You'd subtract it from 1, and then you'd look up this value in the table. Okay. Again, the table is all based on reading to the left of the z-score. Okay.
Are we allowed to retake tests?
So